November 17, 1944, the sun climbs over Ulithi Atoll, a scattered chain of coral islands in the western Pacific, 400 miles southwest of Guam. The morning air is warm and thick with salt. Across the vast turquoise lagoon, something impossible appears on the horizon. A battleship listing to port, smoke still rising from blackened steel, limps through the narrow reef passage. Her forward turret is twisted, her superstructure scarred by fire and shrapnel. She should be heading east, back toward Pearl Harbor, back toward the shipyards of California, to wait months for repair. But she does not turn east. She turns into the lagoon. And there, waiting in the still water like a silent city, are dozens of ships, repair ships, floating dry docks, tenders, barges. They cluster around escort carriers and cruisers, welders sparking in the tropical light, cranes swinging steel plate, men swarming over damaged hulls like ants rebuilding a colony. The battleship drops anchor. Within hours, small boats surround her. Damage assessments begin. By nightfall, welding torches illuminate her wounds. This is not a retreat. This is a repair station, and it is about to change the course of the war. The morning of December 7th, 1941, shattered more than ships. It shattered assumptions. When Japanese bombers roared over Pearl Harbor, they left behind a graveyard of twisted metal, burning oil, and capsized battleships. 8 battleships were hit. The Arizona exploded. The Oklahoma rolled over. The West Virginia sank at her mooring. The scale of destruction seemed total. Admiral Yamamoto hoped the attack would cripple the U.S. Pacific Fleet for a year, maybe longer. Japan's carrier strike force withdrew, confident they had bought precious time to fortify their empire across the Western Pacific. But they miscalculated one critical factor. They did not account for what America could repair and how fast it could be done. Within days, salvage teams swarmed the harbor. The repair ship USS Vestal, herself damaged by 2 bomb hits while moored next to the Arizona, was beached, patched, and returned to service in just 10 weeks. By mid-February 1942, she was back in operation, repairing other vessels. The battleship Pennsylvania, caught in dry dock during the raid, was repaired in weeks and sailed to the West Coast for final work. The Nevada, beached after a desperate run toward the harbor mouth under fire, was refloated, patched, and sent to war. One by one, the sunken giants rose again. The salvage operation at Pearl Harbor became a symbol of American industrial resilience, but it also revealed a harsh truth. The Pacific Ocean is vast. Over 6,000 miles separate Pearl Harbor from Tokyo. Every damaged ship that limped back to Hawaii meant weeks out of action, months in dry dock, and thousands of miles steaming away from the fight. Japan understood distance as a weapon. Their planners assumed the Americans would follow the old rules of naval warfare. A damaged warship returns to a major port. Repairs take time. The fleet operates from fixed bases separated by immense stretches of ocean. This logic had governed naval strategy for centuries. If Japan could force the U.S. fleet to shuttle back and forth across the Pacific for every repair, the Americans would exhaust themselves before reaching Tokyo. Time and distance would bleed the enemy dry. But the United States Navy had been thinking differently. Even before Pearl Harbor, naval planners recognized that the Pacific demanded a new kind of logistics. The old base force, established in the 1920s, had experimented with mobile support. Repair ships, oilers, ammunition ships, and tenders that could travel with the fleet. The concept was simple but revolutionary. Why bring damaged ships back to the port when you could bring the port to the ships? After Pearl Harbor, this idea was no longer experimental. It became doctrine. In early 1942, the Navy began assembling what would become Service Squadron 10, a mobile fleet base unlike anything in naval history. The squadron would include repair ships capable of fixing engines, patching hulls, and rewiring electronics. Floating dry docks that could lift battleships out of the water, tenders to service destroyers and submarines, hospital ships, supply vessels, barges for ammunition and fuel, and even recreation facilities. It would be a shipyard without land, a naval base that moved with the fleet. The mission was brutally simple: keep the warships fighting without sending them home. The Pacific Campaign's early months tested this vision under fire. At Tongatabu in the South Pacific, repair ships like the Vestal worked around the clock. In 60 days, she completed over 900 repair jobs for 50 ships. Damaged cruisers, battered destroyers, submarines with cracked hulls, all were patched and sent back into action. The work was crude, improvised, and exhausting. Crews welded steel plate in tropical heat, working under blackout conditions with Japanese submarines prowling offshore. But the ships kept moving. They stayed in the fight, and Japan began to notice something troubling. American warships that should have been crippled were returning to battle far too quickly. By mid-1943, the United States had learned hard lessons in blood and steel. The naval battles at Coral Sea, Midway, and the grinding campaign for Guadalcanal had proven one thing beyond doubt. Damage control and repair capability could decide who won and who died. At the Battle of Midway in June 1942, the carrier Yorktown absorbed bomb and torpedo hits that should have sent her to the bottom. Repair crews at Pearl Harbor had worked 72 hours straight to patch her up after Coral Sea, getting her back to sea in 3 days when the job should have taken 3 months. She fought at Midway, took more punishment, and nearly survived again before a Japanese submarine finished her off. The lesson was clear. Speed of repair equaled combat power. Japan, meanwhile, struggled with the opposite reality. Their repair infrastructure remained concentrated in home waters. Kure Naval Arsenal, Yokosuka, Sasebo, these were the empire's lifelines. When a Japanese carrier or battleship took damage, it faced a long journey back to Japan. The fleet repair ship Akashi, modeled after the American USS Medusa, was their single purpose-built mobile repair vessel. She was capable and well-designed, but she was alone. One ship could not support an entire fleet across an ocean. Japanese doctrine still emphasized decisive battle, the single great engagement that would annihilate the enemy. They prepared for Jutland in the Pacific. The Americans prepared for a war of attrition. Service Squadron 10 officially formed in February 1944 under the command of Commodore Worrell Carter. His orders were unprecedented: create a mobile base capable of supporting the entire Pacific Fleet at forward locations thousands of miles from any permanent port. The squadron would operate at advanced anchorages, turning remote atolls into functional naval bases within weeks. Carter assembled a fleet within a fleet. Repair ships like the Vestal, Ajax, Medusa, and Hector formed the core. These were not glorified tugboats. They were floating factories. The Ajax, commissioned in late 1943, displaced 9,000 tons and carried a crew of over 1,000 men. Her workshops included machine shops, foundries, electrical repair stations, carpentry shops, optical instrument repair, even a print shop for charts and manuals. She could fabricate parts from raw metal, rebuild engines, and perform structural repairs that would challenge a shoreside shipyard. But the real revolution came with the floating drydocks. Traditional drydocks were massive concrete structures built into harbors. You could not move them, you could not hide them, and you certainly could not tow them across an ocean. The Navy's answer was the ABSD, the Advanced Base Sectional Dock. These were engineering marvels born of necessity. Each ABSD was constructed from multiple sections like building blocks that could be towed separately across the Pacific and then assembled on site. ABSD-2, completed in 1943, consisted of 10 sections. When joined together, the dock stretched 927 feet long, with an internal width of 133 feet. It could lift 90,000 tons. That meant battleships, aircraft carriers. Any warship in the fleet could be hauled out of the water, exposing damage below the waterline for repair. The logistics of moving these docks were staggering. Each section was towed at 4 knots by ocean-going tugs, a journey from California to the forward Pacific taking months. But once in place, they transformed an empty lagoon into a fully functional shipyard. Crews could replace propeller shafts, patch torpedo damage, rebuild rudders, and reinforce hulls. Work that required a permanent dry dock in peacetime could now be done in a coral atoll with no infrastructure beyond what the Navy brought with it. In September 1944, Service Squadron 10 received orders to establish a forward base at Ulithi Atoll in the Caroline Islands. Ulithi was a name most Americans had never heard. It was a ring of coral islands surrounding a lagoon 20 miles long and 10 miles wide, deep enough for any ship, sheltered from storms, and only 1,000 miles from the Philippines where the next great invasion would unfold. The Japanese had occupied Ulithi earlier in the war but left it lightly defended. When American forces arrived on September 23rd, they met no resistance. Within days, the transformation began. Service Squadron 10's ships steamed into the lagoon. Pontoon piers were assembled. Ammunition barges anchored in designated zones. Oilers took position for underway refueling. Repair ships spread across the anchorage, and the floating dry docks, towed piece by piece across the Pacific, began their final assembly. By late October 1944, Ulithi had become the largest naval base in the world. Over 600 ships would pass through the atoll in the coming months. Carriers, battleships, cruisers, destroyers, submarines, transports, every type of vessel in the U.S. Navy found anchorage there. It had no permanent structures, no concrete, no dry docks carved from rock. It was entirely mobile, entirely temporary, and entirely unprecedented. The Japanese High Command watched with growing alarm as reconnaissance flights and intelligence reports revealed what the Americans had built. A phantom shipyard, a base that appeared from nowhere and could vanish just as quickly. And it was working at a pace that seemed impossible. The repair ships, factories at sea. The USS Vestal earned a reputation that bordered on legend. She was old, commissioned originally as a collier in 1909, then converted to a repair ship in 1913. By World War II, she was outdated and overworked, but she refused to quit. At Pearl Harbor, moored outboard of the Arizona, she took 2 bomb hits and absorbed shrapnel and debris when the battleship exploded. Her commanding officer, Commander Casson Young, was blown overboard by the blast, swam back, climbed aboard, and ordered the ship underway. Vestal beached herself to avoid sinking, was patched up, and within weeks returned to service. Throughout the war, she became the most decorated non-combat vessel in the Navy. Her crews worked in shifts around the clock, repairing everything from bullet holes to shattered turbines. She carried machine tools, welding equipment, pumps, generators, and spare parts for systems that had been obsolete for years but were still in service on older destroyers. The newer Vulcan-class repair ships like the Ajax and Hector brought modern capability to the Pacific. These vessels were designed from the keel up for forward repair operations. They carried specialized workshops for every conceivable type of damage. Torpedo hits required structural welding and compartment sealing. Shell damage needed steel plate fabrication. Electrical fires meant rewiring entire sections of a ship. Engine breakdowns demanded precision machining of parts that could not be ordered from a supply depot halfway around the world. The Ajax's crew included machinists, electricians, pipe fitters, welders, carpenters, optical technicians, and specialists in everything from boiler repair to radar calibration. They did not just patch holes, they rebuilt ships. Floating drydocks, engineering marvels. The ABSD-2 floating drydock at Ulithi became the centerpiece of the repair effort. Assembling it took weeks. Each section had to be precisely positioned and connected. Ballast tanks were tested, pumping systems calibrated. The dock worked on a simple but effective principle. Flood the tanks and the dock sinks low enough for a ship to enter. Pump out the water and the dock rises, lifting the ship clear of the ocean. Once the hull was exposed, repair crews swarmed over it. The scale of work possible in these docks was extraordinary. After the Battle of Leyte Gulf in October 1944, the cruiser USS Canberra arrived at Ulithi with a massive torpedo hole in her side. In a traditional scenario, she would have been towed back to Pearl Harbor, a journey of thousands of miles taking weeks, followed by months in a permanent dry dock. Instead, she entered ABSD-2. Welders sealed the torpedo damage, engineers reinforced bulkheads. Within days, she was afloat again. Within a few weeks, she returned to combat. Smaller floating dry docks, the YFD class, handled destroyers and submarines. These were more portable, easier to position, and perfect for vessels that needed quick turnaround. A destroyer with a damaged propeller could be lifted, repaired, and back on patrol in under 72 hours. The efficiency was relentless. Forward base strategy. Ulithi as the secret weapon. Ulithi Atoll was more than a repair depot. It was a statement of strategic intent. The Japanese had spent years fortifying islands across the Pacific, building air bases, bunkers, and supply depots. The Americans bypassed many of them, seizing lightly defended atolls instead and turning them into logistics hubs. Ulithi epitomized this strategy. It had no value as a fortress. Its value was its location and its lagoon. Admiral Chester Nimitz himself visited Ulithi in early 945 and stood on the deck of a repair ship looking across hundreds of vessels anchored in neat rows. He understood what this place represented. It was industrial power made mobile. It was America's ability to project not just firepower but manufacturing capability across an ocean. The anchorage operated with ruthless efficiency. Ships needing minor repairs anchored near repair vessels and received work parties within hours. Those requiring dry dock time entered the queue and were processed in order of urgency. The most heavily damaged were triaged. Could they be saved in a forward area, or did they need to go back to Pearl Harbor or the West Coast? The decision was made quickly. Time equaled combat power. Every day a ship spent idle was a day the enemy gained. The Japanese could not match this tempo. Their logistics remained centralized, their repair capacity remained in Japan, and their ability to sustain continuous operations across the Pacific eroded month by month. Human element, skilled workers at sea. The men who made this system work were not warriors in the traditional sense. They were machinists, welders, electricians, shipfitters, men whose skills were forged in the factories and shipyards of America's industrial heartland. Many had never seen the ocean before the war. They came from Pittsburgh steel mills, Detroit auto plants, New York dockyards. The Navy trained them quickly and shipped them west. Aboard repair ships and in floating dry docks, they worked under conditions that would have shut down any civilian operation. Tropical heat turned steel decks into griddles. Humidity rusted tools overnight. Monsoon rains flooded workspaces. And always, there was the threat of air raids. Japanese planes occasionally found Ulithi. Submarine alerts sent ships to battle stations in the middle of repair jobs, but the work continued. These men improvised constantly. A cruiser needed a replacement part for a turbine that had been discontinued years ago. The machine shop crew fabricated it from scratch, working from hand-drawn blueprints and measurements taken with calipers. A destroyer's radar system failed, and the optical technicians rebuilt the waveguide assembly using parts cannibalized from 3 other damaged units. There were no second chances, no luxury of ordering replacements. If a ship could not be fixed with what was on hand, it had to sail 3,000 miles for proper repair. So the crews made do. They adapted. They invented. Their workshops became laboratories of practical engineering, where textbook procedures gave way to whatever worked under pressure. The pace was punishing. Repair crews worked 12-hour shifts, sometimes longer during major operations. When Task Force 38 returned from strikes on the Philippines or Formosa, dozens of ships arrived needing work simultaneously. Prioritization became an art form. A carrier with flight deck damage took precedence over a destroyer with a jammed gun mount. A battleship with steering problems outranked a cruiser with a leaking fuel tank unless the cruiser was about to sink. Damage control parties assessed every vessel, categorized the work, and assigned resources. The repair ships operated like emergency rooms in a war zone, triaging the wounded and saving who they could. Japanese perspective, shock, and strategic miscalculation. Japanese naval intelligence tracked American ship movements with increasing confusion. After major engagements, they counted damaged vessels retiring from the battle zone. Weeks later, those same ships reappeared on the front lines. It did not make sense. A carrier hit by bombs at the Battle of the Philippine Sea in June 1944 should have been out of action for months. Instead, it returned in weeks. A battleship photographed with visible damage near Samar in October was back in the bombardment line by November. The numbers did not add up. Either American ships were far more survivable than Japanese intelligence believed, or the Americans had developed repair capabilities that defied conventional understanding. Reports from captured American sailors and intercepted communications gradually revealed the truth. The United States had built mobile shipyards. They were operating from forward anchorages with capabilities that matched or exceeded major naval bases. Japanese commanders struggled to accept this. Their own experience with forward repair was limited. The Akashi could handle significant work, but she was one ship, and her capacity was finite. The idea of an entire fleet of repair vessels supported by floating dry docks large enough for battleships seemed extravagant to the point of impossibility. Japan's industrial capacity was already stretched thin. Steel, skilled labor, and resources were allocated to building new warships, not creating mobile repair infrastructure. The strategic assumption had always been that damage would force American ships back to Pearl Harbor or the West Coast. If that assumption was wrong, the entire calculus of attrition warfare collapsed. Admiral Ugaki Matome, Chief of Staff to Admiral Yamamoto and later commander of the 5th Air Fleet, wrote in his diary about the frustration of facing an enemy that refused to stay damaged. He noted that American carrier groups operated with a resilience that suggested either extraordinary luck or extraordinary logistics. The truth was logistics, but by the time Japanese planners fully understood this, it was too late to counter it. Japan could not replicate the system. They lacked the shipbuilding capacity, the trained personnel, and most critically, the safe forward anchorages. American submarines and aircraft dominated the sea lanes. Any attempt to establish a similar mobile repair base would have been hunted and destroyed. Supply chain innovation, underway replenishment revolution. The repair capability was only part of a larger revolution in naval logistics. Alongside the repair ships and dry docks, the Navy perfected underway replenishment. Oilers pulled alongside warships at sea and pumped fuel while both vessels steamed at 15 knots. Ammunition ships transferred shells and bombs using high lines and cargo nets. Refrigerated supply ships delivered food. Fast combat support ships, a new class developed during the war, combined oiling, ammunition transfer, and general supplies in one hull. This meant carrier task forces could remain at sea for months without returning to port. They refueled every few days, replenished ammunition after strikes, took on replacement aircraft and pilots from escort carriers acting as ferry vessels. And when damage occurred, repair ships met them at prearranged coordinates or at forward bases like Ulithi. The Japanese had developed their own underway refueling techniques before the war and initially surpassed American capabilities. But they never scaled the system to support prolonged operations. Their logistics remained tied to fixed bases and convoy schedules. When American submarines began sinking Japanese tankers and supply ships at a catastrophic rate, the entire system broke down. By 1944, Japanese carriers sometimes returned to port not because of battle damage, but because they had run out of fuel or ammunition. Their mobile striking power, once the terror of the Pacific, became increasingly tethered to shrinking supply lines. The contrast was stark. American task forces roamed the Western Pacific, striking targets from the Philippines to Formosa to the Japanese home islands, operating continuously for weeks. When they needed repair or resupply, they withdrew to Ulithi, spent a few days at anchor, and returned to action. The Japanese combined fleet, still potent on paper, struggled to maintain operational readiness. Fuel shortages limited training. Damaged ships waited months for repair. Skilled crews were lost faster than they could be replaced. The Americans had not just built a better repair system, they had built a sustainable war machine. June 19, 1944, the Battle of the Philippine Sea erupts west of the Mariana Islands. It will be remembered as the Great Marianas Turkey Shoot, a catastrophic defeat for Japanese naval aviation. American carrier fighters slaughter Japanese attack planes by the hundreds. But the battle also tests the American repair system under the most extreme conditions. The carrier USS Bunker Hill takes a bomb hit near the base of her island superstructure. The blast kills dozens and starts fires that rage across 2 decks. Damage control parties flood magazines to prevent an explosion. They seal compartments. They fight the fires with foam and seawater. After 3 hours, the fires are out. The ship is damaged, but operational. She withdraws from the battle and makes for Eniwetok Atoll, where Service Squadron 10 has established a forward base. At Eniwetok, repair crews swarm aboard. The bomb damage is severe. Steel is twisted, wiring is melted, ventilation systems are wrecked. In a traditional naval campaign, Bunker Hill would sail back to Pearl Harbor. Instead, she stays at Eniwetok for 3 weeks. Repair ships provide steel plate, welding equipment, and hundreds of skilled workers. The carrier's own crew works alongside them. By mid-July, Bunker Hill is patched, tested, and ready. She sails west to rejoin the fleet. The Japanese expected her to be out of action for months. She was gone for weeks. The same pattern repeats across the fleet. The light carrier USS Princeton, damaged by near-miss bombs, receives hull repairs at Eniwetok and returns to service. Destroyers with cracked superstructures from heavy seas are welded and reinforced without leaving the forward area. Cruisers with damaged propulsion systems have turbines dismantled, repaired, and reassembled by repair ship crews working around the clock. The tempo is relentless. After the Philippine Sea Battle, Admiral Raymond Spruance's Fifth Fleet needs maximum strength for the coming invasion of the Marianas. Every ship matters. Every repair, no matter how improvised, keeps another hull in the fight. October 1944 brings the largest naval battle in history. Leyte Gulf, 4 separate engagements over 3 days, kamikaze attacks, surface gun battles, torpedo spreads in the night. When the smoke clears, Japan's navy is shattered, but American losses are significant. The escort carrier USS St. Lo is sunk by the first organized kamikaze attack. Other carriers are damaged. The cruiser USS Canberra takes a torpedo from a Japanese aircraft and loses power. She is dead in the water, a sitting target. The cruiser USS Houston is also torpedoed. Both ships should be abandoned. Instead, the Navy decides to tow them. The operation is nicknamed Crip-Div 1, the Crippled Division. Destroyers and cruisers surround the 2 damaged ships, screening them from air and submarine attack. Tugs take them under tow. The entire formation crawls toward Ulithi at 5 knots. Japanese planes attack repeatedly. Combat air patrol fighters shoot down dozens. The convoy survives. Both cruisers reach Ulithi, and there, the floating dry docks wait. ABSD-2 takes the USS Canberra first. The cruiser is flooded in her engineering spaces, listing, her hull torn open by the torpedo blast. Salvage pumps have kept her afloat during the tow, but the damage is catastrophic. The drydock floods its ballast tanks and sinks low in the lagoon. Tugs carefully position Canberra over the submerged deck. Divers check alignment. Then the pumps engage. Slowly, steadily, the dock rises. Water pours from the ballast tanks. The cruiser emerges from the lagoon like a wounded whale being hauled onto a beach. When the dock stabilizes, the full extent of the damage is visible. A section of hull plating 20 feet wide is simply gone. The torpedo warhead vaporized steel, twisted frames, and ripped apart machinery spaces. Fuel oil still seeps from ruptured tanks. In any other navy and any other war, this ship would be written off as a constructive total loss. Not here. Not now. Repair crews erect scaffolding against the damaged hull. Welders begin cutting away twisted metal. Shipfitters measure the void and calculate what is needed. The repair ship USS Ajax pulls alongside the dry dock and begins fabricating steel plates to exact dimensions. Her workshops run triple shifts. Metal is heated, formed, cut, and delivered. Within 72 hours, new hull plating is being welded into place. Electricians rewire damaged systems. Pipe fitters replace shattered steam lines. Carpenters rebuild interior compartments. The work is not elegant. It is functional, expedient, and driven by a single imperative. Get this ship back to war. 12 days after entering the dry dock, Canberra floats again. Her repairs are temporary, but they are sound. She has power, she has propulsion, she can fight if needed, though her combat effectiveness is reduced. The plan is for her to return to Pearl Harbor for final repairs, but the fact that she can make the journey under her own power is itself a victory. The Houston follows the same process. Torpedo damage, dry dock, fabrication, welding. 12 days later, she too is patched and operational. 2 cruisers that should have been lost are saved, and the Japanese, monitoring radio traffic and reconnaissance flights, are left to wonder how the Americans are doing this. November 1944. Ulithi becomes the epicenter of the Pacific War's logistical miracle. On any given day, over 400 ships occupy the anchorage. Aircraft carriers line up for fuel and ammunition. Battleships take on provisions. Destroyers receive replacement parts. And always there are damaged ships waiting for repair. The routine becomes almost industrial in its efficiency. A destroyer arrives with a jammed 5-inch gun mount. A work party from the repair ship Hector boards within an hour. They disassemble the mount, identify a broken recoil mechanism, fabricate a replacement part, and reassemble the gun. Total time 18 hours. The destroyer refuels, takes on ammunition, and returns to her task group. A light cruiser reports chronic engine trouble. She anchors near the USS Ajax. Engineering specialists board and spend 2 days diagnosing the problem. A turbine blade has cracked, causing vibration and efficiency loss. Normally, this requires dry docking and engine removal, a job taking weeks at a major shipyard. Instead, the Ajax's machine shop fabricates a replacement blade from raw steel. The cruiser's engineers, working with Ajax's specialists, replace the blade without removing the turbine. The repair takes 5 days. It is not perfect. The blade will need proper replacement eventually. But it works. The cruiser steams out of Ulithi at full speed. The scale of work is staggering. Service Squadron Ten's records show that between October 1944 and March 1945, repair ships at Ulithi completed over 4,000 individual repair jobs. These range from replacing light bulbs to rebuilding entire propulsion systems. Floating dry docks handled over 60 major repairs, including battleships, carriers, cruisers, and large auxiliaries. The average time a damaged ship spent at Ulithi was 9 days. 9 days from arrival to departure, fully or partially repaired, and back in action. The Japanese operating from bases in Japan proper averaged 3 to 6 months for comparable repairs. The mathematics of attrition shifted decisively in America's favor. January 1945 brings new challenges. Task Force 38, under Admiral William Halsey, conducts raids on the South China Sea, striking Japanese convoys in ports from Formosa to Indochina. The operations are aggressive and costly. Kamikaze attacks intensify. The carrier USS Ticonderoga takes a kamikaze hit that kills over 100 men and starts massive fires. She fights her way back to Ulithi, her flight deck shattered, her hangar deck gutted. Repair crews assess the damage and determine she cannot be fixed in the forward area. She will need Pearl Harbor or even the West Coast. But before she leaves, Ulithi's repair ships patch her enough to make the journey safely. Temporary flight deck sections are welded in place. Fire damage is sealed. Electrical systems are jury-rigged. She sails east under her own power, and 4 months later, after full repairs, she returns to combat. Not every ship can be saved in the forward area, but the triage system ensures that those which can be saved are saved quickly, and those which cannot are stabilized for the journey home. The alternative, abandoning damaged ships or attempting long tows without repair, would mean greater losses. Ulithi and the mobile repair fleet become the difference between a wounded ship returning to fight and a wounded ship lost forever. March 19, 1945. The carrier USS Franklin, operating off the coast of Japan, takes 2 bomb hits from a single Japanese dive bomber. The bombs penetrate the flight deck and detonate in the hangar bay, where fully fueled and armed aircraft are spotted for launch. The resulting explosions are apocalyptic. Fires rage across the ship. Secondary explosions hurl aircraft and debris into the air. Over 800 men die in the first minutes. The ship lists. Power fails. For hours it seems Franklin will sink, but her crew fights with desperate courage. They flood magazines. They push burning aircraft overboard. They seal compartments and restore partial power. The cruiser USS Pittsburgh takes Franklin under tow. Destroyers screen them from further attack. Against all odds, Franklin survives. She makes it to Ulithi, barely afloat, her hull scorched black, her superstructure twisted wreckage. This time, even Ulithi's capabilities are exceeded. Franklin is too damaged for forward repair. But Service Squadron 10 stabilizes her. They pump out flooded compartments. They reinforce damaged bulkheads. They restore enough power for her to steam slowly under her own power. Franklin begins the long journey back to the United States. She will never fight again, but she makes it home. Her survival is a testament not just to her crew's heroism, but to the system that kept her afloat long enough to reach safety. The Japanese had hit her with everything they had. She should have sunk. The fact that she did not was another kind of victory, one written in welding scars and improvised repairs. The numbers tell a story that words struggle to capture. Between 1943 and 1945, Service Squadron 10 and its associated repair units conducted over 20,000 repair jobs across the Pacific Theater. These ranged from minor tweaks to complete overhauls. Floating dry docks at Ulithi, Manos, Eniwetok, and Guam handled hundreds of major repairs that would have otherwise required ships to return to Pearl Harbor or the West Coast. The time savings were immense. A cruiser needing drydock repairs that would take 30 days at Ulithi and then return to action had effectively saved 60 days of transit time compared to sailing back to Hawaii. Across hundreds of ships and thousands of repairs, this translated into months of additional combat presence. The fleet stayed forward. The pressure on Japan never relented. The Japanese, by contrast, saw their repair capacity collapse under the weight of accumulated damage and dwindling resources. By 1944, many of Japan's major warships were operating with unrepaired damage from previous engagements. The carrier Shokaku, a veteran of Pearl Harbor, Coral Sea, and multiple campaigns, was finally sunk at the Philippine Sea in June 1944. She had been hit before, but always returned to action after repairs. This time, American submarines caught her. She went down with heavy loss of life. But even before her sinking, she had been operating below full capability for months. Repair facilities in Japan were overwhelmed. Spare parts were scarce. Skilled labor had been drafted into other industries or killed in air raids. The shipyards at Kure and Yokosuka, once the pride of the Imperial Navy, worked under constant threat of American bombing. The contrast in damage control doctrine also played a decisive role. American ships were designed with survivability in mind. Compartmentalization, redundant systems, and extensive firefighting equipment gave crews the tools to save their ships. Damage control training was rigorous and universal. Every sailor knew how to fight fires, seal leaks, and shore up bulkheads. Japanese ships, designed for offensive power and speed, often sacrificed these features. Watertight integrity was less robust. Fire suppression systems were less comprehensive. Crew training emphasized gunnery and torpedo tactics over damage control. When Japanese ships were hit, they tended to suffer cascading failures. A single bomb could start fires that spread uncontrollably. A single torpedo could flood multiple compartments. American observers noted that Japanese warships, ton for ton, were often more fragile than their American counterparts. This difference extended to the repair process. Even when Japanese ships made it back to port for sale, the work took longer. The centralized nature of Japan's repair infrastructure created bottlenecks. A damaged battleship might wait weeks for dry dock space to become available. Once in the dock, repairs proceeded slowly due to material shortages and competing priorities. The Navy needed new construction to replace losses. The Army needed munitions. Civilian industry needed steel. Everything competed for limited resources. By late 1944, some damaged warships were cannibalized for parts to keep others operational. The super battleship Shinano, converted from a battleship hull to an aircraft carrier, was sunk by an American submarine on her maiden voyage before ever seeing combat. She was rushed into service partially incomplete because Japan needed carriers desperately. The fact that she was not fully ready reflected the systemic collapse of Japan's naval logistics. American naval intelligence tracked these developments with clinical precision. Code breaking revealed Japanese frustration with repair delays. Intercepted messages spoke of fuel shortages, parts shortages, and the impossibility of maintaining operational readiness. Photo reconnaissance showed damaged ships sitting idle in Japanese ports for months. Submarine patrol reports confirmed that Japanese warships spent more time in harbor than at sea. The mobile repair capability gave the United States a compounding advantage. Not only could American ships be repaired faster, but the act of repairing them forward meant Japanese forces faced a constant, unrelenting enemy presence. There was no respite, no time to reorganize, no chance to recover from losses. The Americans simply kept coming. By the spring of 1945, Ulithi Atoll had become more than a repair base. It had become a symbol. To the American sailors who passed through, it represented security, efficiency, and the industrial might of a nation that could project its power halfway around the world. To the Japanese, it represented something far more ominous. The Americans had solved the tyranny of distance. They had turned the vastness of the Pacific from a defensive barrier into an irrelevance. No matter how far from home, no matter how damaged, American ships could be restored and returned to battle. The strategic implications were devastating. Japan's entire defensive concept relied on bleeding the enemy across thousands of miles of ocean. If the enemy refused to bleed, if the enemy could repair and resupply at will, then the defense was meaningless. The human cost of this capability is harder to quantify but no less significant. Thousands of repair personnel, men whose names never appeared in battle reports, worked in obscurity to keep the fleet operational. They endured tropical diseases, heat exhaustion, and the constant stress of working under threat of air attack. Ulithi was struck by Japanese aircraft on several occasions. In March 1945, a kamikaze broke through the defenses and crashed into the carrier USS Randolph while she was anchored in the lagoon. The blast killed 25 men and injured over 100. Repair crews from Service Squadron 10 swarmed aboard immediately. Within hours, firefighting and damage assessment were complete. Within days, temporary repairs were underway. Randolph was patched, tested, and sailed to Pearl Harbor for final repairs. She returned to combat in time for the Okinawa campaign. The speed of response saved the ship and the lives of many of her crew. The medical support infrastructure at Ulithi also played a critical role. Hospital ships like the USS Solace and USS Samaritan provided advanced surgical care for wounded sailors who could not wait for evacuation to rear-area hospitals. Men injured in kamikaze attacks, explosion survivors with severe burns, sailors pulled from sinking ships with crush injuries and hypothermia all received treatment in floating hospitals anchored in the lagoon. The survival rate for serious injuries was dramatically higher than in previous wars. This was medicine practiced under combat conditions with limited supplies and improvised techniques, yet it matched or exceeded the standards of stateside hospitals. The recreation facilities at Ulithi, though primitive, offered psychological relief in a war zone where stress and fatigue accumulated relentlessly. Small islands within the atoll were designated for rest and relaxation. Sailors could go ashore, play baseball, drink beer, and escape the confines of their ships for a few hours. Mogmog Island became famous across the fleet as a place where you could walk on solid ground, breathe air that did not smell of fuel oil and sweat, and pretend for a moment that the war was far away. These brief respites helped maintain morale during campaigns that stretched for months without break. The logistical sophistication extended beyond repair and resupply. Ulithi hosted mail distribution centers, personnel transfer stations, and even a floating bakery that produced fresh bread for the fleet. Ammunition barges were organized by type and caliber, allowing ships to replenish quickly without confusion. Fuel oil was stored in tankers positioned across the anchorage, enabling multiple ships to refuel simultaneously. The entire operation ran on meticulous planning, radio coordination, and the labor of thousands. It was a city without buildings, a factory without foundations, and it functioned with a precision that impressed even the most skeptical observers. Post-war assessments by both American and Japanese analysts confirmed what had become evident during the final year of the war. The mobile repair and logistics system was a decisive strategic advantage. Japanese Admiral Yonai Mitsumasa, who served as Navy minister, later stated in interviews that Japan had underestimated American industrial and logistical capabilities. The assumption that distance and attrition would favor the defender proved catastrophically wrong. The Americans did not fight the war Japan expected. They fought a war of machines, production lines, and supply chains. Every damaged ship repaired at Ulithi was a ship that did not need to travel 6,000 miles for repair. Every day saved was another day of combat operations. The cumulative effect broke the back of Japanese resistance not through a single climactic battle, but through sustained, unrelenting pressure that allowed no recovery. The legacy of Service Squadron 10 and the floating repair capability influenced post-war naval doctrine profoundly. The United States Navy retained the concept of mobile logistics support and expanded it during the Cold War. Repair ships remained part of the fleet. Underway replenishment became standard procedure. The idea that a Navy could operate indefinitely at sea, sustained by a mobile support structure, became fundamental to American naval strategy. The Soviet Union studied the Pacific Campaign and developed its own mobile logistics fleet. Other navies followed. The lessons learned at Ulithi, Manus, and Eniwetok shaped naval thinking for generations. For the men who built and operated the floating shipyards, the war's end brought little recognition. They were not fighter pilots or submarine commanders. They did not lead charges or win medals for valor, but they won the war in their own way, one welding seam at a time, one machined part at a time, one hired ship at a time. When the Japanese surrendered in August 1945, Service Squadron 10 was still operational, still anchored in forward bases, still ready to repair and sustain a fleet that no longer needed to fight. The ships were decommissioned, the floating drydocks towed back to storage, and the men went home. But what they had accomplished remained. They had turned the Pacific Ocean, once an impassable barrier, into an American highway. And on that highway, the war was won not just by those who fought, but by those who kept the fighters in the fight. Wars are decided by many things, courage certainly, strategy without question, but also by the unseen labor of those who build, repair, and sustain. The floating workshops of the Pacific Theater were not glamorous. They did not win dramatic victories. They did not appear in newsreels or headlines. Yet without them, every other victory would have been harder, slower, or impossible. The genius of the American approach was not in any single innovation, but in the willingness to rethink the very nature of naval warfare. For centuries, navies had been bound to their ports. Damage meant retreat, distance meant delay. The Pacific forced a new answer: bring the port with you, make the fleet self-sustaining, turn logistics into a weapon as potent as any gun or torpedo. The Japanese generals who finally understood what the Americans had achieved must have felt a cold, sinking realization. They had prepared for the wrong war. They had built a navy designed for decisive fleet engagements, for honor and glory in battle. The Americans built a navy designed to win through endurance, through industrial power, through the unglamorous but unstoppable machinery of repair and resupply. The battleships and carriers got the glory, but the repair ships and floating dry docks won the war. In the end, the Pacific Campaign was decided not by who could strike the hardest blow, but by who could endure, repair, and return to strike again. And in that contest, there was never any doubt who would prevail. The factories of Detroit and Pittsburgh, the shipyards of Norfolk and San Francisco, the machine shops aboard repair vessels anchored in coral atolls 10,000 miles from home. These were the true arsenals of victory. The war was won not only on the front lines, but in the workshops, the dry docks, and the tireless labor of those who kept the fleet afloat. History remembers the battles, but the battles were made possible by those who repaired the ships, fabricated the parts, and refused to let distance or damage stand in the way of victory.